Hello, students, and welcome to this micro lecture about the Pythagorean theorem. This is an important concept because it's used to calculate linear distances. It's applied in many practical situations. Architects, engineers, surveyors, landscapers, and scientists use this formula. What's the Pythagorean theorem? A formula for a right triangle. Who is Pythagoras? One of his many quotes that I chose here was, "Choose always the way that seems best, however rough it may be." Pythagoras, 570 to 495 BC. He was an Ionian Greek philosopher who founded a secret communal school of metempsychosis. I included the word communal because they actually lived at the school and were a community that practiced healthy eating diets and different kinds of philosophies, and it was kept secret. And I chose the word Ion Greek because back in the years back around BC, it was a different location than what we know as the location for Greece today. He was a mathematician and a scientist, lover of wisdom, and this I didn't know. Aristotle called him a wonder worker, supernatural, a legend in his lifetime. You can Google him to find out a lot more. It's quite a history. Pythagoras is credited with discovering a right triangle formula called the Pythagorean theorem. Now, a right triangle has a right angle in it. The letters in here, A, B, and C, are large in red for the angles. And the C is right here where the right angle is. It's 90 degrees. Why is it called the right angle? Because back in those early days, they looked everywhere and there were squares with right angles everywhere and rectangles. Side C, the hypotenuse, is in small letters. It's the longest side. It's always opposite the right angle. Sides A and B are called legs. Now you can swap those. This could be B and this could be A. And then these letters here for the angles would change appropriately. They are shorter. They always come out of the right angle. The hypotenuse is always the longest side. The Pythagoras theorem helps engineers to solve right triangle problems. We have rotating right triangles because in real life they do move around. So this C, it represents the hypotenuse. Let's see what happens here. I rotate it and it doesn't look like even the same triangle, but there's the hypotenuse. Here's another one rotated. It's exactly the same shape but turned. And if you look at all four, they do look like they're different triangles. That's why labeling is very helpful. The formula, a squared plus b squared equals c squared, where these are the two legs. So it's leg squared plus leg squared equal hypotenuse squared. We're going to solve for the hypotenuse c, and we'll do this on the next screen. C equal the square root of a squared plus b squared. So the square root of the sum of the legs. We'll do this proof on the next page. This triangle is a famous 3, 4, 5, so I automatically know that's 5. We're going to use our formulas to prove that the formula does work. The right angle has this to designate it. These are the legs A and B. It could also be A and B and C for the hypotenuse. Now, let's start here. We're going to swap and bring our c squared over to the left because we want to solve for it. And then we just take these, move it to the other side. They're still equal. Now we want to undo the squares, so we have just c. The opposite is to square root it. The opposite of a c squared is c. Now over here, we square root the whole entire side, not just the individual terms. Now we substitute, that is, we replace, so a, I'll just choose 3 here, so it's 3 squared plus the other leg, which is 4, 4 squared. 3 squared is 9, that means 3 times 3. 4 squared, 4 times 4 is 16. And then I'm going to add them, and they become the square root of 25. Now, the square root of 25, some of us have it memorized, is 5. But how it is, the square root of a number is, we want the number that will be times itself, and this is considered the base, and that would be the square root. So 25 is made up of 5 times 5, so 5 is the base, 5 squared. So you undo the square root, undoes that square, 5 is your answer. Bam. Now, what happens if you have harder ones? We use the TI-8384, which looks like this. The second key is this blue key up here. The x squared, which also has a square root on it, is right in here. You press that key, type in the number you want, hit enter, and voila, you'll have your answer. Why does this work? Because of the right triangle shape. Watch this carefully. It's a geometry proof. What they did is they said take 3 and draw a square over here. So 3 squares and 3 squares. 3 times 3 gives you 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Here's 4. So a 4 by 4 square, 1, 2, 3, 4. 4 times 4 gives you 16. And up here we take this and we have 1, 2, 3, 4, 5. And we have 5 times 5 is 25. What happens is you add the 9 and the 16, and they will always add to the hypotenuse squared 25. So that's what I've written over to the side here. So step 1 and step 2, basically, they're equal. Here's an everyday problem where the Pythagorean theorem is useful. We have a ladder. How high up the wall can James lean this 11-meter ladder if the base of the wall, if the base of the ladder is 4 meters from the wall? Now, this is a leg. Can you see the right angle? This is the hypotenuse, and here is another leg. Now, notice that we have substituted x, the unknown, for the letter b, for the leg. So now let's go ahead over here. We have our original formula, a squared. Instead of using b squared, just put the x in there because it's a leg. But we want to solve for the x that's unknown because we have this and this. Watch this carefully. To move a squared to the other side, I can subtract a squared minus a squared, goes to 0. And then I subtract c squared minus a squared. Now, the next step. To solve for the x squared, to undo a square, we square rooted it. We got the base of x, and we put the square root over the whole side. Now, notice 2 things. We have a minus sign in here, and b has been replaced by x. Let's substitute. X is unknown. C always is the longest side, so 11 squared, 11 times 11, 121, minus, because we're subtracting the leg off, 4 squared is 4 times 4 is 16. They subtract to 105. Now to find the square root, the answer is 10.247, which rounds to 10 meters. Since this case 10 is good enough, we definitely want to use our TI-8384. So we press the second key, x squared, 105, and you'll get 10.247 and a lot more numbers. I rounded it to 10. Your goals. Recognize when to use the Pythagorean theorem. Piece of cake. Whenever you have a right triangle, you can use this formula. Be able to use this formula to calculate distances for any side of a right triangle. And we use the c squared equal a squared plus b squared, which we've just practiced in 2 problems. 3, be able to demonstrate these goals in your assignment and an exam. So there you go. Check out your assignment in Canvas. Welcome and thank you so much for listening.